The ECDIS is a special-purpose computer loaded with software to aid navigation. It cannot and does not replace good navigational skills, good seamanship, or good judgment. The ECDIS displays the ship's position on electronic charts. These are very different from the traditional paper chart. Electronic vector charts may provide more information, as well as automatic alarms. To navigate safely, the watch-keeping officer must be properly trained in ECDIS operation and understand how to manage the actual ECDIS equipment they are using. Their training must include generic training in the technology of ECDIS and familiarization acceptable to the ship's flag state on the specific model on the bridge. Although every ECDIS provides the functions required by the IMO, each manufacturer has a different approach. In this video, we will not concentrate on any single manufacturer. Watch-keeping officers must be able to find what they need in the equipment menus and be confident of making adjustments to the settings when appropriate. First, let's take a look at what's provided by the screen display. The display shows a vector chart with the real-time GNSS position of own ship superimposed on it. The display usually includes the ship's course line and a heading vector that indicates where the ship is predicted to be by the ECDIS. This vector is based on time, and the value can be adjusted by the officer. Alongside the chart display is a panel which shows numerical navigational information. With appropriate settings, the ECDIS will provide indications and alarms for all charted hazards. We will be looking at these settings later. In addition, many ECDIS have the potential to show overlays, such as AIS, radar, T&P notices, and target tracking information. The officer of the watch needs to take great care when using any of these overlays, as they can clutter up the screen and obscure essential navigational information. It's good practice to keep the target tracking and collision avoidance information displayed on a separate screen. Keeping ground avoidance and collision avoidance data separate makes these two essential tasks easier to manage. The ECDIS display can help increase situational awareness, as it brings together on one screen information which used to be available only from different areas of the bridge. That does not mean that the officer must stay in front of the ECDIS. Far from it. It's essential to walk around the bridge and check the other nav aids and the outside view. They must correlate this information with the ECDIS display. At all times, they must maintain a proper and effective lookout. Watch-keeping officers must understand that the precise look of the display and its ease of use can all lead to over-reliance. To avoid this, officers need to understand the basis of electronic charts. All ECDIS use electronic navigational charts, ENCs. These official vector charts are made up of digital data which describe chart objects. The data includes coordinates, giving the items position, and attributes which give them shape and identify what they are. It's simple with chart objects such as buoys, but more complicated with areas. These are made up of vectors to build shapes. So a coast will have a number of areas representing the different depth contours of the hydrographic data. This is the same data used to make paper charts. But unlike a printed symbol on a piece of paper, the vector chart objects can be identified by the computer software and calculations made about them. For example, to get all the information on a particular point, just put the cursor on it and click. These pick reports are available on all ENCs. For an area on the chart, the computer can, with appropriate settings, highlight the depths sufficient for safe navigation, shown here as the white and pale blue areas. Using the chart data and the ship's electronic position, the ECDIS can calculate how close the ship is to the planned track, shown here as a dashed orange line. If the ship goes further off the course than has been allowed for in route planning, this will set off an alarm. The limits set for deviation from the course line, the cross-track limits, are shown here as solid orange lines. Different ECDIS display these in different ways. In areas where ENCs are not yet available, raster charts may be used. These do not have the same capabilities as ENCs. So, in short, the hydrographic chart information may be the same as on a paper chart, but in an ENC it is stored digitally in a very functional way that enables the watch-keeping officer to adapt the display. There are 3 modes of display set by the IMO. The first is called the display base. This information is permanently on the screen. It should only be used to get an overview of an area. It is not intended to provide sufficient information for safe navigation. The second is called the standard display. This is intended to provide the minimum amount of information for safe navigation and route planning. It shows everything in the base display, but adds boundaries of fairways, buoys, and other aids to navigation. The list of information shown in these displays can be found in the workbook that accompanies this video. The display can always be switched to show the standard display by pressing a single button on the ECDIS console. The third mode is called the All Other Information display. This includes everything in the standard display and all the available additional information, including spot soundings, place names, and other navigational information. The information is there so that the watch-keeping officer can select what is required. For navigation, the watch-keeping officer needs to adapt the display to show an appropriate amount of useful information at all times. This will be determined by the surroundings, the traffic, the company procedures, master standing orders, and their own preferences. To provide the ECDIS with information on ownership, it must be connected to 3 sensors. These are a speed log, a gyro compass, and a position fixing system. This is almost always provided by a satellite-based system. Many ECDIS are connected to additional sensors such as echo sounders. Note that none of these sensors are perfect. Any errors in their calculations will be passed on to the ECDIS and will affect its display. That's why watch-keeping officers must keep checking other navigational equipment and the outside view from all angles to ensure that there's no mismatch of information. It's worth noting that to keep the ship in line with mandatory requirements, it is only legal to use official charts, ENCs, on an ECDIS. Masters and watchkeeping officers must realise that the use of non-official or private charts can be dangerous and may also cause serious problems with the authorities. The ship's dimensions and manoeuvring characteristics, including its turning circle, are usually set up during installation of the ECDIS. To ensure that the display is clearly visible under all lighting conditions, there are several presentation settings. The day display will have a light background and darker foreground details. The night display will have a dark background with light foreground detail. The dusk display also has a dark background and can be used in conditions of low light. The two-colour display, available on all ECDIS, shows in the daylight presentation the deep area that is safe for navigation in white. The shallow, unsafe area is deep blue. There is a solid dark line between the two. This display indicates simply where the ship can go safely and where it must not go. In the night setting, the safe area is usually black. The shallow area light grey with a solid light-coloured line between them. Many ECDIS also have a four-colour scheme, giving a more detailed picture. It's useful in confined waters. In the daylight presentation, it shows the deep water as white, with a light blue for navigable water. The non-navigable water is shown as a deeper blue, with dark blue for very shallow water. The contour values depend on the chart's database. The colour area boundaries depend entirely on the ship's depth settings. In the night setting, the colours are usually reversed, but still show clearly the four areas. The watchkeeping officer must select the display that is appropriate to the situation. On most ECDIS, the brightness of the display is adjustable by the user. We are now going to deal with the depth settings that need to be input for each voyage. The ECDIS provides a panel to input these essential depth settings. The precise arrangements of these panels vary from ECDIS to ECDIS. The most important setting is the safety contour. This determines the boundary of the no-go areas. The safety contour value also determines the display of the symbol for isolated underwater dangers, which are less deep than the safety contour, but which lie within the safe waters defined by it. In daylight presentation, the safety contour is shown on the chart as a solid dark line that separates the safe navigable waters from the non-navigable waters. In the night presentation, it is usually a white line. The safety contour is calculated by adding the ship's current draft to additional factors. These include a required underkeel clearance, a safety margin, and allowances for squat, height of tide, and the expected sea state. The displayed value will always default to the next deepest depth contour for which the ECDIS has depth information. This will always increase its numerical value. The safety contour value is crucial to the anti-grounding capability and alarms of the ECDIS. The safety contour value will be discussed and agreed by the master and navigating officer for all legs of all voyages during route planning. All watchkeeping officers must check the value of the safety contour when they come on watch. They need to understand why the setting has the numerical value it has been given. There's another important depth value, the safety depth. This determines how spot soundings are shown. Spot soundings equal or less than the safety depth will be displayed in black, those greater in grey. There are two more depth settings. These are required to determine the boundaries of the four-colour presentation. The first is the shallow contour. This could be set as the draft of the ship, as this contour will determine the darkest non-navigable area of the chart in daylight presentation. On many ECDIS, there is also a deep contour. This indicates a depth below which safety is assured, so, for example, it could be set at twice the maximum draft or more. This gives the deep water area of the chart and the chart's palest colour in the daylight setting, seen here in white. Like all depth settings, these settings will default to the next deepest value for which the chart has hydrographical data. The safety contour and safety depth must be set up during voyage planning in line with company requirements, the conditions and the master's standing orders. These settings should be continuously checked during the voyage. Inshore passages and deep-sea passages may have different requirements, as do loaded and ballast voyages. Investigations of the groundings of ships using ECDIS frequently show that the safety contour and safety depth settings were inappropriate or simply not set at all. All ECDIS have a look-ahead function. This provides a vector zone ahead of the ship. The shape varies between different manufacturers. The size of the zone is determined by the time length set by the navigating officer. Its direction will be the ship's current heading. The zone is always clearly indicated and moves forward with the ship. Alarms, such as the safety contour alarm, will be generated when the look-ahead zone touches an area less deep than the safety contour. This zone is active both during route monitoring and route planning. Once the master has asked the navigating officer to prepare a route, the officer checks that all the ENCs required are up to date. When updating, only use the memory sticks dedicated for the ECDIS. Never use other memory sticks, as these may contain viruses. The next step is to collect all the necessary information that is not in the ECDIS. This is likely to include port and pilot information. As part of the planning process, the officer must check up-to-date notices to mariners, navigational warnings, T&Ps, and weather information. The route must always comply with the company procedures and the ship's safety management system. The next step is to construct a draft route. This can either be done by adapting an existing route or starting from the beginning. Waypoints can be added by putting the cursor on the required position on the chart and clicking, or by putting the latitude and longitude of positions in a text box. The ECDIS automatically joins up the waypoints to construct leg lines. The ECDIS will automatically select the best available chart. If there is a larger scale chart, the system will indicate this. If unfamiliar with the area, the officer should check the quality of the chart information. Once the draft route has been made, the waypoints and leg lines can then be altered to optimize it. Adjusting the position of the waypoints is generally easy. This is simply done by dragging and dropping them using the cursor. During planning, the ECDIS will generate a list of the waypoints. This will show the position, the length of the leg, and other information. With this ECDIS, the safety speed and cross-track limits are put into this list. A very important variable that must be decided during route planning is the cross-track distance. This provides permissible limits to the ship's deviation from the planned course. Different ECDIS will have slightly different ways of showing these track limits. Here they are shown as a thin red line to port and a thin green line to starboard, either side of the hatched course line. An alarm is generated if the ship goes outside the set track limits. This cross-track distance will usually be large in deep-sea passages, but much smaller in ports and confined waters. The navigating officer must review the safety contour and safety depth setting for each leg of the route to ensure that they are appropriate. Inshore, an allowance must be made for manoeuvring to avoid other traffic. The cross-track limits must be appropriate for each leg of the route. If they are not, the result is likely to be frequent, inappropriate and unwanted alarms. If a sharp turn is required, it may be that to take into account the ship's turning circle, the waypoint itself will be outside the route's track limits. Once the route is complete, the navigating officer should go through it using the chart in its original compilation scale to check visually for all potential hazards. The ECDIS can find charted hazards, but it cannot replace the knowledge and understanding of an experienced navigator. So this is an essential part of route planning. Once that is completed, the automatic safety check can be started. The ECDIS will only check between the cross-track limits. This is why they must be appropriate for each leg of the voyage. The reason for each alarm and indication that appears during the automatic safety check must be identified and steps taken to address it. It is an essential part of the navigating officer's duty to carry out both the visual check followed by the automatic safety check. This helps ensure that the planned route is as safe as possible and minimises inappropriate alarms that can lead to alarm fatigue. The completed route is discussed with the master. Final approval by the master is the last step in route planning.
0.25? Yes, 0.25, okay.
The task of the watchkeeping officer is to keep the ship navigating safely along the planned route. And the ECDIS has a lot to offer in helping achieve this. The display shows the ship's position as determined electronically, surrounded by a circle with a course and speed vector of chosen length indicating several minutes. There will also be a heading indicator, usually a solid straight line. Usually, a past track record can be displayed. The ECDIS generates alarms and indications for potential hazards, including going outside the cross-track limits. When enabled, the Look Ahead function will generate an alarm if it crosses the safety contour. That is, provided the settings are appropriate for the current leg of the voyage. Keeping inside the cross-track limits, shown here as solid orange lines, is important, as only this area has been checked for charted hazards. The watch-keeping officer must check all the settings at the start of every watch. Appropriate settings are essential to manage the alarm functions and ensure that only relevant alarms sound. The ECDIS automatically stores the course made good, the time, position, heading, speed, and other chart and navigational data. But watch-keeping officers must regularly check the integrity of the sensors supplying the ECDIS with information. They need to watch the outside view and move around the bridge. They must never rely solely on the GNSS position displayed on the ECDIS while route monitoring. They must routinely check the ship's position, especially in coastal waters. This can be done using position lines from visual bearings and by radar ranges from radar conspicuous objects. Radar parallel indexing should be used to monitor the ship's position in restricted waters. The ECDIS will automatically bring up the next chart required. All ECDIS can show the situation north up in true motion. Most can also display course up and relative motion. Although zooming into the chart is easy, officers need to be very cautious about this. When the scale is larger than the compilation scale, this is called overscaling. Many ECDIS show warnings for this, here indicated as dark vertical lines. The accuracy of the display can no longer be trusted, and detail may be lost. The watch-keeping officer must zoom out. Route monitoring must never be done on an overscaled chart. Underscaling is the opposite effect. Here the display is zoomed out to a smaller scale than that which is available. Greater detail is generally available with the chart displayed at a larger scale, or on a larger scale chart. It is essential to have a backup to an ECDIS. Often this is a second separate ECDIS. This must be fully functioning while the ship is underway. It will be following the same route plan. It can be used to show a larger area ahead than that used on the main ECDIS. It provides an ideal facility for watchkeepers to get on the bridge early and review the upcoming legs of the voyage without interfering with the current navigation. They must check the safety settings and the cross-track limits. Remember, only the area between the cross-track limits will have been checked for charted dangers. It is essential to have a proper watch handover, which includes the course, the route plan, weather, machinery status, and the traffic situation, as well as the ECDIS settings. The ECDIS does help watch-keeping officers maintain good situational awareness, but they must constantly check the integrity of the information being sent to the ECDIS to have a good overview of the system's status. Many ECDIS have the capability of overlaying further navigational information. But watch-keeping officers need to be very cautious about doing this, because the screen can get crowded and essential information may be lost in clutter. Target tracking and collision avoidance information must be kept on a separate screen. The ECDIS is neither designed nor approved for collision avoidance. So it's good practice to use two screens, one for navigation and grounding avoidance, and another for collision avoidance. In coastal waters, overlaying the radar picture on the ECDIS for a brief time can be helpful in checking positional accuracy. If there is an offset, the watch-keeping officer must immediately resolve the problem using visual or other fixes to determine both the ship's position and also to identify the defective sensor. In some circumstances, a radar overlay may also be used for seeing more clearly the safe water available for manoeuvring around targets. It can also make clearer the position of the targets relative to buoys and channels. When using radar overlays, officers must remember all their knowledge and understanding of radar. AIS information can be very helpful in some situations. For example, giving indication of other ships' predicted tracks. Always remember that AIS information depends on the input of the other ship, and so may not be accurate. Also remember that many small vessels do not have AIS. So watch-keeping officers must never forget the importance of maintaining a proper and effective lookout. Overlays on the ECDIS can provide additional support to help the watch-keeping officer maintain good situational awareness. They need to be wary of cluttering up the display and trying to do too much on one screen. The ECDIS is capable of showing everything, but if it is used to do so, important information risks being obscured. Watch-keeping officers must balance their time between the ECDIS, the radar and target tracking devices, and the outside view. They need to manage the bridge team and maintain a proper and effective lookout. The ECDIS has a lot to offer the watch-keeping officer. It integrates the output from the GNSS, speed and compass sensors to provide a real-time display with a plot of the ship's position and motion on the chart. It provides automatic route monitoring with warnings of charted hazards. At night, it provides chart information without loss of night vision. It provides the navigating officer with easier chart updating, quicker route planning and route editing. It provides easy calculation of times of arrival and can reduce the chance of human error. Perhaps the greatest challenge to the watch-keeping officer is the false sense of security that ECDIS may produce. The display always appears highly accurate, but it depends on the accuracy of the chart data, the input from the sensors, and appropriate management by the officer. Officers must routinely cross-check the accuracy of the ECDIS displayed data. They should question any unusual ECDIS messages or system behavior. Suitable depth settings are essential to avoid unnecessary alarms. These can lead to alarm fatigue when bridge officers ignore them or even turn them off. Officers need to be aware that there will be regular developments and improvements in ECDIS, and they will need to keep up to date with these changes. It is good practice to carry out regular exercises simulating ECDIS failure. These are likely to increase watch-keeping officers' understanding of the strengths and limitations of the equipment. They must always assess the potential threats to the safe navigation of the ship by all available means. The ECDIS is an effective aid to safe navigation. For watch-keeping officers to get the best from it, they require proper training accompanied by good seamanship and good situational awareness. Read the workbook that accompanies this video for further advice and information.